Hello everyone, welcome back from the weekend. This week we are looking at just one video lesson, and this is it. I think once we get into it, by the time we're done, you'll find it to be relatively simple, but there's kind of a lot of explaining to do to get there. So bear with me as we go through this. So we are solving quadratic equations. Quadratic means it's going to have x squared in it. Solving a quadratic equation means that it's going to be set equal to 0, and we need to actually find the solution. And the main way we're going to do that is by factoring, which you will see. We've already practiced factoring last week. But before we do that, we're going to learn sort of a prerequisite skill, which is solving with the square root method. It's called the square root method. So we'll start out with a few of those problems. Then we'll get to common factoring and trinomial factoring, and we'll utilize something called, oops, that's supposed to be a highlighter, the zero property of multiplication. But like I said, before that, we're going to do this square root method. So basically, we're going to solve an equation, just like you've always solved equations. We're going to do various steps that you go through, like if there's a plus, you do minus, and then you do it to the other side of the equal sign, or if it's times, you divide both sides, stuff like that. It's just we're going to be using the square root as a step in the process. And as a general rule, something you're going to need to learn and carry with you through this is that whenever you use a square root to solve an equation, you get a plus-minus solution, just like in absolute value equations. If you remember when we did absolute values, at some point you split into two answers, one positive, one negative. Basically, if x squared equals 9, this is just a random example. If x squared equals 9, then x could be 3, right? Because 3 squared equals 9. Or x could be negative 3. Negative 3 squared, meaning negative 3 times negative 3, is also 9. So when you square a negative, it turns positive. So we would write it like this. If you had an equation, x squared equals 9, you want to isolate the variable, of course, which means you want to cancel out the 2, the square. To cancel out a square, use square root. They cancel each other out. And just like with every equation, you have to do the same thing to the other side. But when you see the square root of 9, generally think, oh, 3, there's my answer. When you use a square root to solve for a variable, like I said before, you could get either a plus 3 or a minus 3. So you end up with two solutions, x equals positive 3 or x equals negative 3. So we're going to get into that first. We'll go through a few examples. Then I'll come back to the common and trinomial factoring and this zero property of multiplication. So, how does this break down? Well, the first page, the first 6 problems, we're going to use the square root method, solve by taking square roots. And as always, I'll do the evens. I'm going to ask you to do the odds. Okay, so number 2, here's our variable. We want to isolate it. We want to solve it. So we need to cancel out the minus 4, cancel out the times 8, cancel out the square. To start this off, I am going to add 4 to both sides of the equal sign. Cancel out that minus 4, you get 8n squared equals 72. Then divide by 8. Since it's times 8, of course you divide. Always do the opposite. You get n squared equals 72 divided by 8 is 9. And this is pretty much what I just did up here. To solve for n now, to cancel out a square, you have to take the square root of both sides, cancel out that square. N equals 3, but it could be positive 3 or it could be negative 3. I have a feeling when I go down, scroll down to check the answer, they'll the publisher that does this these papers that I make, they tend to use this type of notation. I'm not going to ask you to do that. You don't have to do that, but I'm guessing that's what it's going to look like. So let me scroll down, and yep, there it is. Okay, let's just do a couple more for practice, and then we'll get into the next type of problem. Number 4. So I'm going to add 2 to both sides. I get 64x squared equals negative 1 plus 2, which is 1, minus 64 on both, no, not minus, duh. That's times, so of course we need to divide by 64. That cancels out. You get x squared equals 1 over 64. And then to cancel out the square, again, you use the square root. That cancels that out. You get x equals. Okay, when you use a square root, you get a plus minus. That's automatic. That's always going to happen. What's the square root of 1 over 64? I don't know if you've had to opportunity to think through square rooting fractions before, or if it's been taught to you, or I don't even remember if I've gone over it. But basically, square root of 1 over 64, you just do the square root of 1 over the square root of 64. So this becomes plus or minus, square root of 1 is 1, square root of 64 is 8, plus or minus 1/8, or negative 1/8 and positive 1/8 in those funky little brackets. Okay, that's going to be the last time I write my answer like that. It's just too much writing. Pain in the anatomy. And there it is. That's right. Okay, let's look at number 6. Okay, so 430 is a big number. Don't let that scare you. It should work out just fine. Minus 7 on both sides. 9b squared equals 423. 423. Now we got to divide by 9. B squared equals. All right, 9 goes into 42 6 times, that's 36. 42 minus 36 is 63. 63 divided by 9 is 6. Okay, time for a calculator. In fact, I'm going to split the screen. 423 divided by 9. 47. I wasn't even close. I wasn't even close, for crying out loud. Well, I did doubt myself, which means, in a way, that I'm really smart. Okay, anyway, so now to solve for b, square root cancels out a square, do that to both sides. Put down the plus minus, that's going to become automatic when you use this square root method. It's just what you do. And then you look at 47. Can you square root 47? No, it's a decimal. It's one of those infinite decimals, so guess what? You just leave it square root 47. The answer is plus minus square root of 47. Or at least it should be when I go down to check it, number 6. And there it is, positive square root of 47, negative square root of 47. Okay, so that's how the first 6 problems go. Again, this is not the main topic today. The main topic is solving by factoring. But I just hope you see that this is a method that you can use as long as you know whenever you do a square root, you have to put a plus minus on your answer. And notice that yields 2 answers. So it's very common for you to get 2 answers when you solve quadratic equations. Now, from here on out, we get into solving by factoring. We cannot do the previous method here because you've got the variable p in 2 different places, and they're not like terms. One is p squared and one is p. So you can't really isolate the p and square root it. It just doesn't work. You'd have something like p squared equals, so if you brought this over and this over, 14p minus 48, and you try to do this square root method to cancel that out, now what? Square root of 14p, that's a variable. You can't work that out. You can't get an answer. So the square root method fails. The reason it fails essentially is having the p in there twice, or the variable, whether it's x, y, z, whatever. Having that in there twice is what goofs it up. So we're going to solve this by factoring. Let me scroll back up for a minute. So last week we reviewed factoring. It is an Algebra 1 skill. We're going to use common factoring in a little bit, and trinomial factoring. So common factoring is the one that's like the distributive property in reverse. Trinomial factoring is the one that's like the FOIL method in reverse. And then we're going to use something called the zero property of multiplication. Let me take just a second to explain that. Let's make up 2 variables. So let's say I've got a and b, and you don't know what a is and you don't know what b is. They're in my head. I've made them up. They're my numbers. They're unknown to you. But I tell you that if you multiply a and b together, you will definitely get 0 for an answer. You should be able to just use your logical reasoning and deductive skills to tell me something. You should definitely know something. Either a would have to equal 0 or b would have to equal 0. In order to multiply 2 numbers together and get 0 for an answer, at least one of them has to be a 0. Or they could both be 0. So if a times b equals 0, then either a equals 0 or b equals 0. Why is that important? Well, I got to put it all together here. I'm going to use an example to do it. So we got p squared minus 14p plus 48 equals 0. I'm going to factor this. It's a trinomial, right? 1, 2, 3 terms. That means try. So this is like the FOIL method backwards. You put a p here and a p here, we need two numbers that multiply to 48 and add up to negative 14. Well, if you recall, the one method I showed you to do this, 1 times 48, 2 times 24, 4 times 12, oh, 3, I skipped 3. I think 3 times 16, and then 6 times 8, and the next would be 8 times 6, so I get the same numbers backwards. And in order for them to multiply to positive 48 and add up to negative 14, I'd have to look at the cases where they're both negative. Negative times negative equals positive. So which pair of those adds up to negative 14? It's going to be right here, negative 6, negative 8. Negative 6, negative 8. Okay, so what I have here are two things, right? This is a thing. This is a thing. All right, thing is not the appropriate term. They are factors. That's what they're called. Two factors that multiply together, yeah, parentheses next to parentheses means times, to equal 0. So if two things or two factors multiply together to equal 0, that means either this one equals 0 or this one equals 0, or they both equal 0. So we go on the assumption that they could both equal 0 and then solve them both. If we solve this one, you add 6 to both sides, you get p equals 6. To solve this one, you add 8 to both sides, p equals 8. And those are the two answers. Just like up here, two answers. If you notice in these, the two answers were the same. Here, the two answers are different, 6 and 8. Let me go down and check number 8 and make sure I did it right. And there it is, 6 and 8. So that's the idea. You factor the trinomial, set each factor equal to 0, and then continue to solve each one. So how's this one going to factor? X times x. Okay, without making a little chart off to the side here, just think this through. What numbers will multiply together to equal 1 and add up to equal 2? Well, the only option is 1 and 1. In fact, it's got to be positive 1 and positive 1. So I get x plus 1 equals 0 and x plus 1 equals 0. I mean, if you get the same one twice, are you supposed to set them both equal to 0? Honestly, it's not going to matter that much because you solve them. Get x equals negative 1. Oops, leave room for the negative. Solve this one. Obviously, it's going to be the same. X equals negative 1. You get the same answer twice. You don't really have to write the answer twice. It is just the answer in that case. If you happen to get the same answer twice, that's good enough. So negative 1 is the answer, as opposed to writing negative 1 twice. But the same idea. Factor it, set each factor equal to 0, and then continue to solve. All right, let's look at number 12. Factor it, m, two numbers that multiply to 2 and add up to 3. Again, I don't think we really need to make the chart off to the side, on this one. It's kind of unnecessary. 2 times 1 is 2, right? And positive 2 plus 1 is 3. So factor it, set each factor equal to 0, and then continue to solve. So minus 2, m equals negative 2, minus 1, m equals negative 1. Those should be the two solutions. For number 12, there it is, negative 2, negative 1. All right, let's look at number 14. Now, number 14 is not a trinomial. There's only two terms here. If you count 1, 2, 3, you're kind of doing it wrong. Don't count the other side of the equal sign, just on this side of the equal sign. There's only two terms here. So that means trinomial factoring might not work. So what do you do instead? Well, instead you do common factoring. Both of these terms have an x in common, so you can factor out that x. If you pull out or distribute out, undistribute the x, you're left with x minus 7. But we do have two things, two factors multiplied together. X is a factor, and then in parentheses, x minus 7 is a factor, and they are multiplied together. So when two things multiply to equal 0, set each one equal to 0. So this one, compared to the others, could look confusing because we're using that different type of factoring. We're doing the common factoring. And this one isn't in parentheses like the other examples. That's okay, you still set it equal to 0. The next step is to solve it, but this one's already solved. I mean, the x is isolated. The other one, we do have to add 7 both sides, so yeah, go ahead and do that. And now we get two answers, 0 and 7. Let's go check number 14. 7 and 0, 0 and 7, same thing. Number 16, kind of the same thing, just extra practice. Both terms have the variable n, so you factor out an n. If you factor it out, you're left with 7n minus 6. Set each factor equal to 0, and then solve them. This one's already solved. This one, we do have to solve, and it doesn't look like it's going to work out all nice and neat, right? When you divide by 7, you can't divide 6 by 7. Do not grab a calculator and type in 6 divided by 7. You'll just get an ugly decimal. It's fine just to leave your answer as a fraction, 6/7. So 0 and 6/7 should be the answer, and there it is. Okay, only a couple more, so hopefully you're catching on. This is going well. Oh, but wait. Do you recall from last week that when you do trinomial factoring and you have a lead coefficient, that it gets a little more complicated? So let's talk about how this is done. So you multiply these together. 5 times 2 is 10. And then make your little chart. What can you multiply together to get... I'm totally blanking out on this. Good grief. Yeah, what multiplies together to equal 10? 1 and 10, 2 and 5, right? Yeah. Which of those, and they do have to be positive. There's no negatives anywhere. Which of those add up to 7? Well, it's 2 and 5. So 5n squared plus 2n plus 5n plus 2 equals 0, right? So we split this 7 into 2 and 5, or 7n into 2n and 5n. Now, split this in half. What can you factor out of the first half? An n. That's 5n plus 2. And what can you factor out of the second half? Really nothing. If you can't factor anything out, you just factor out a 1. And that's okay because these match, and that's what we want after all. So we have 5n plus 2, and then n plus 1. Remember, what's left over here and here becomes the second factor. Now set each factor equal to 0. 5n plus 2 equals 0, n plus 1 equals 0, and solve both of those. Looks like this one's going to give me a fraction, because when I divide by 5, 5 won't divide into 2. I'll just leave that negative 2/5. This other one's pretty easy though, just subtract 1, and we get our answers there, negative 2/5 and negative 1. And there it is. Wow, I struggled through that one, and I really don't know why. I felt like my brain was just shut off for a minute there. Yeah, if you have any issues with this, go back and rewatch the lesson on factoring. I go in depth on how to work these out. So number 20, kind of the same way. Multiply these together. 10 times negative 2 is negative 20. And now break it down into anything that could multiply to give you negative 20. So that could be negative 1 times positive 20, or positive 1 times negative 20. 2 times 10, plus minus minus plus, what, 4 times 5, plus minus minus plus. Anything else that'll multiply to equal 20? No, that's it. Now, which pair of those will add up to equal negative 1? Remember, if there's no number in front of x, you count it as a 1. What numbers will multiply to add up to negative, or not multiply, which numbers will add up to equal negative 1? That's going to be positive 4 and negative 5. So I write 10x squared plus 4x minus 5x minus 2. Okay, having done that, we split this in half. Out of the first half, I'm going to do common factoring. And let's see, 10 and 4 can both be divided by 2. And since both terms have an x, you can divide by x. That gives me 5x plus 2. The next two terms, 5x and 2 don't have anything in common, but they do both have negative signs, so I can factor out a negative 1. If you divide those both by negative 1, you get positive 5x plus 2. And what's supposed to happen? These match each other. They do. So one factor is 5x plus 2. The other factor is going to be 2x minus 1. And now that it's factored, set each factor equal to 0. All right, so here, minus 2, 5x equals negative 2, divide by 5. We get negative 2/5 for one answer. The next one, add 1 to both sides. 2x equals 1, divide by 2. 1/2 for the second answer. Negative 2/5 and positive 1/2, and there it is. Okay, so your job is to do the odds. I think you'll find they start out fairly simple. If you can just follow my examples, you should be fine. When you get down to 17 and 19, where these lead coefficients here kind of mess things up, that's where, if you're going to have a challenge, I expect it would be on those two. Please reach out to me if you have trouble. Either send me an email, show up to the live session when we do this. I can answer questions here. I can work through them with you. Contact a friend, whatever. But if you have trouble, please don't just struggle. Seek out some help. All right, until I talk to you again, have a great